List of popular machine learning algorithms. 1. Linear regression. To understand the working functionality of linear regression, imagine how you would arrange random logs of wood in increasing order of their weight. There is a catch, however, you cannot weigh each log. You have to guess its weight just by looking at the height and girth of the log, visual analysis, and arranging them using a combination of these visible parameters. This is what linear regression in machine learning is like. In this process, a relationship is established between independent and dependent variables by fitting them to a line. This line is known as the regression line and is represented by a linear equation y equals a asterisk x plus b. In this equation, y, dependent variable, a, slope, x, independent variable, b, intercept. 2. Logistic regression. Logistic regression is used to estimate discrete values, usually binary values like 0/1, from a set of independent variables. It helps predict the probability of an event by fitting data to a logit function. It is also called logit regression. These methods listed below are often used to help improve logistic regression models. Include interaction terms. Eliminate features. Regularize techniques. Use a nonlinear model. 3. Decision tree. Decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly it is preferred for solving classification problems. It is a tree-structured classifier, where internal nodes represent the features of a dataset, branches represent the decision rules, and each leaf node represents the outcome. Decision trees usually mimic human thinking ability while making a decision, so it is easy to understand. The logic behind the decision tree can be easily understood because it shows a tree-like structure. 4. SVM, Support Vector Machine, Algorithm. SVM algorithm is a method of a classification algorithm in which you plot raw data as points in an n-dimensional space, where n is the number of features you have. The value of each feature is then tied to a particular coordinate, making it easy to classify the data. Lines called classifiers can be used to split the data and plot them on a graph. 5. Naive Bayes algorithm. A naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. Even if these features are related to each other, a naive Bayes classifier would consider all of these properties independently when calculating the probability of a particular outcome. A naive Bayesian model is easy to build and useful for massive datasets. It's simple and is known to outperform even highly sophisticated classification methods. 6. KNN, K-nearest neighbors, algorithm. This algorithm can be applied to both classification and regression problems. Apparently, within the data science industry, it's more widely used to solve classification problems. It's a simple algorithm that stores all available cases and classifies any new cases by taking a majority vote of its k-neighbors. The case is then assigned to the class with which it has the most in common. A distance function performs this measurement. KNN can be easily understood by comparing it to real life. For example, if you want information about a person, it makes sense to talk to his or her friends and colleagues. Things to consider before selecting k-nearest neighbors algorithm. KNN is computationally expensive. Variables should be normalized, or else higher range variables can bias the algorithm. Data still needs to be pre-processed. 7. K-means. It is an unsupervised learning algorithm that solves clustering problems. Data sets are classified into a particular number of clusters, let's call that number k, in such a way that all the data points within a cluster are homogeneous and heterogeneous from the data in other clusters. How k-means forms clusters? The k-means algorithm picks k number of points, called centroids, for each cluster. Each data point forms a cluster with the closest centroids, i.e., k clusters. It now creates new centroids based on the existing cluster members. With these new centroids, the closest distance for each data point is determined. This process is repeated until the centroids do not change. 8. Random forest algorithm. A collective of decision trees is called a random forest. To classify a new object based on its attributes, each tree is classified, and the tree votes for that class. The forest chooses the classification having the most votes over all the trees in the forest. Each tree is planted and grown as follows. If the number of cases in the training set is n, then a sample of n cases is taken at random. This sample will be the training set for growing the tree. If there are m input variables, a number m less than, the value of m is held constant during this process. Each tree is grown to the most substantial extent possible. There is no pruning.